Hello everyone, this is the fifth lesson of physics, 6.5 Characteristics of Sound Waves, page 136, 137. Sound waves, some terms used when you will study about sound waves. Frequency and pitch. Frequency, we already explained the frequency in the previous lesson. Today we will talk about pitch. Frequency and pitch, they are the same. They give the same meaning, but they use it in different ways. Sound waves are caused by vibrations. If you look at this speaker, the speaker cone or this one, it moves forward and backward. So the movement, this movements forward and backwards, it makes or it causes the air particles here to compress, to squash, and to stretch. So sound waves are a series of compressions and refractions. Frequency, it's now what? It's a number of oscillations per second. It's called frequency. It's measured with hertz. Here, as you can see, these waves, okay? Here we have three different waves. They differ from each other by their frequency. If you will focus, or you will see, here it's one wave, okay? Here it's making more waves, and here it's more. So the difference among these three waves, it's what? It's their frequency. They differ by their frequency. Now, pitch. Definition for pitch is the degree of highness or lowness of a tone. We use pitch to represent how high or low is the sound. Now, if you look at these two different waves, okay, each one, the main difference between them, it's what? It's the number of waves. Okay, here we have 1, 2, 3, 1, 2, 3, 4, and so on. So the question here, the question will say, what is the difference between these two waves? Maybe someone will say they differ by their frequency. It's correct. They differ by their frequency, and also they differ by their pitch. Which one has higher frequency? This one. Which one has lower frequency? This one. Which one has higher pitch? This one. So now, pitch equal to P equal to F. Okay, pitch equal to, it's same as frequency. So the higher the pitch is, the higher the frequency will be. Hearing range. Because we said each wave, it has they differ by their frequencies. So we as humans, we are able to hear or detect frequencies that it range from 20 hertz up to 20,000 hertz. What's that mean? Any sound that has frequency below 20, less than 20, we cannot hear it. Any sound that has frequency which is above 20,000 hertz, also we cannot hear it. So here we have this table, it shows some different kinds of voices or sounds, okay, with their frequencies. For example, drum note, the frequency of it, it's 20 hertz. Low note, high note, okay, they differ by their frequency also. Whistle, it's about 10,000 hertz, and here 20 and above, it's upper upper limit of hearing 20,000. Above 20,000 we are not able to hear this sound. If you look at this picture here, it shows the piano. It's the piano note. Okay, this piano, it gives different sounds. Okay, but why it gives different sounds? Because each one, this piano is divided into many octaves. Okay, each octave, it gives sound with specific frequency. Okay, so octaves, musical scales are based on this. Okay, if the pitch of a note increases by 1 octave, the frequency doubles. How? What's that mean? Here we have octave number 1, octave number 2, 3, and 4. If you will look at the first one, it gives sound with frequency which is 64 Hertz. If you will move to the next octave, you will see what happened to the frequency. It doubled. It was 64, now it's 128. The same thing if you will move to the next one. It was 128, now it's 256, and so on. Okay, so if the pitch note increase by 1 octave, the frequency doubles. Here, if you look at these two oscilloscopes, you will see here it's a sound from 2 octaves. Okay, but the sound from 2 octaves represented on this oscilloscope. As you can see here, the sound has a higher pitch. This sound has higher pitch than this one. How do we know? It depends on the frequency. As you can see here, the frequency of this wave, it's more or it's higher than the frequency of this one. So in the exam, maybe you'll have a question. You'll have like these two drawings, and the question will say, which one has, which oscilloscope is showing a higher frequency? So what do you think? This one. Maybe also a question will say, which oscilloscope it shows a higher pitch? You will say this one. The wave equation. As we explained in the previous lesson, we said waves, we can calculate some terms about waves. For example, we can find the speed, frequency, wavelength. How they are related to each other, or how they affect on each other. Frequency and wavelength. Here it's the relation between frequency and wavelength. The higher the frequency, the shorter the wavelength. What's that mean? The wave equation. This equation applies to sound waves. We said when you will study about waves, you need to use this equation. This equation, it says speed equal to frequency times wavelength. For example, if the speed of sound in air is 300 meters per second, the sound waves of frequency 110 Hertz have a wavelength of 3 meters. Sound waves of frequency 330 Hertz have a wavelength of 1 meter. Now, focus on these numbers. These numbers, it represent what? 110. It represents the frequency. When the frequency is 110, how much is the wavelength? It's 3 meters. When the frequency is 330, how much is the wavelength? 1 meter. So what you can find from this, we can find that, or we can find that the higher the frequency, the shorter the wavelength. So frequency, when frequency increase, the wave length, it will decrease. Amplitude and loudness. Amplitude and loudness, or when you are talking about amplitude, you are talking about how loud or soft the sound is. Amplitude, we explained amplitude, the meaning of the word amplitude in the previous lessons, and we said it's the maximum distance the oscillation can reach. Now, if you look at these two oscilloscopes, the difference between the waves shown here, it's what? They differ by their amplitude. This wave, it's going higher than this one, okay? So, the amplitude in this one, it's higher than this one. So, what's that mean? Now, if the question will say, which sound wave it gives a louder sound? It's louder, the first one or the second one? The answer will be this one, the first one. Why? Because you will say the amplitude is more here. So the sounds displayed on the oscilloscope screens above have the same frequency. Frequency 1, 2, 3, 4. Four waves. Four waves. 1, 2, 3, 4. They have the same frequency, but they differ by what? They differ by their amplitude. So the oscillations in the air are bigger and the amplitude of the wave form is greater. Okay. Now, sound waves carry energy. Doubling the amplitude means that 4 times as much energy is delivered per second. Quality. The word quality here is very important to understand it. What do you mean by the quality here is middle C on a guitar. Middle C on a guitar does not sound quite the same as middle C on a piano, and its waveform looks different. The two sounds have a different quality or timbre. What do you mean by quality here? Quality here is a term we used to distinguish two waves, two sound waves. For example, if you have, we will use it in another way. It's like if you have apple, okay? In apple, maybe the apple will be red, maybe will be yellow, or will be green. Still, three of them are what? Are apples, but they differ from each other by, for example, their taste. Okay, so here is what they mean by quality. Even, for example, if you will use violin and the family of violin, the instruments of violin, the family of it, it's like all of them, when you will look at them, it seems they will give the same sound, but they will give the same frequency, but in different way. So here it's what do you mean by quality? It means different sounds from same instrument. Questions. Assume that the speed of sound in air is 330 meters per second. Here are the frequencies of 4 sounds. A, 400, 150, 500, 200. Which sound has the highest pitch? Now, here they didn't mention anything about pitch. They mention about what? About frequencies. Now, if you remember, we said pitch, it's equal to frequency. So the higher the frequency, the higher the pitch is. Now, which one is the highest pitch? So the answer will be C. B. Which two sounds are 1 octave apart? What's that mean? If you remember this one, the octaves, okay? Which one, which it's 1 octave apart. What's that mean? It's next to each other. Now, how we will know? We said when you will move from 1 octave to the next one, the frequency it will double. So which two hertz or which two frequencies they show a double each other? So the answer will be A and D. It's 200 and here it's what? It's 400. So they double each other. C. Which sound has the longest wavelength? Now, here what we will have? We will have the relationship between frequency and wavelength. We said as much as the frequency will increase, okay, so the wavelength will decrease. So now, which one has the longest? Because we want the longest wave, so we should look for the least frequency. So the answer here will be B. Question number 2. Why does a piano not sound quite like a guitar even if both play the same note? Here we say they differ by what? It's because of the quality. They differ by the quality. Number 3. A sound is picked up by a microphone and displayed as a waveform on an oscilloscope. How would the wave change if the sound had a higher pitch? Okay, if the sound will have a higher pitch, what will happen? Peaks closer together. What's that mean? Pitch, we said it's same as frequency. So let's say now this is the wave, but if you will increase the pitch, what will happen? The peaks will be closer to each other. Okay, now if you will compare between this distance from here to here and this distance from this one to the next one, you will see will be closer. The peaks will be closer to each other. B. The sound was louder. Okay, when we say loud, how loud the sound is, we are talking here about amplitude. Amplitude. So here, what will happen when the or how the sound when it will be louder? What will happen? The peaks will be higher. Yani, if you want to display it, let's say this is normal now, but when the sound will be louder, it will be in this way. Okay, so what is happening? The amplitude it's increasing. Question number 4. The lower limit of a human hearing is 20 hertz. The upper limit is 20,000 hertz. What is the upper limit in kilohertz? Kilohertz, here what we have kilo and here it's hertz. We just need to convert from kilohertz into from hertz into kilohertz. So we will convert from small to big. So what we will do from small to big, we will divide by how much? By 1000. So the answer will be 20,000 1000 over 1000. So the answer will be 20. 20 kilohertz. B. What is the wave length at the lower limit? How to find the wavelength? We will use this formula. Speed equal to frequency times wavelength. Okay, or we can use this symbol. Okay, now how much is the speed? It's 330. How do we know it's 330? From the beginning they said assume that the speed is 330. Okay, how much is the frequency? Frequency here they are talking about the lower limit. The lower limit, it means what? It means 20 times wavelength. Now wavelength equal to 330 above 20, and the answer would be 16.5. 16.5 meter. The third one, it's a homework. You should do it by yourself. And thank you. Have a good day.